Uh, Hello. Yeah. Hey, hi everyone. My name is Ananth. I'm a cloud solution architect at Intel and focusing on cloud native infrastructure and accelerated computing. It's my first VMware conference, and I'm really excited to be here. With me is Igor.
Yes, hi, I'm Igor Becerra. I'm the Global Account Manager for VMware at Intel. So pleasure being with all of you here.
Okay. So today, I'd like to discuss with you why Intel and VMware are great together, why we are such a great team, and also I would like to change the perspective of vCPUs, how you use them, because the CPUs are getting smarter. It's getting workloads can be accelerated. It can further reduce the TCO, improve the security. So I'll walk you through all these details in the coming slides. For many of us, vCPUs are mostly a check mark. If you provision X number of vCPUs, you're mostly done with it. Your application would run, and you would only look back when there's a performance issue. And traditionally, we address those performance issues by adding more vCPUs. You add more vCPUs, and it works. But things are changing. It no longer can scale this way. So what we are doing is that with every vCPU you add, you're also getting accelerators. These are specific accelerators to accelerate your particular workload. But this does not change the way you're provisioning the vCPUs. Even though your CPUs are getting smarter, you can still provision the way you're provisioning the vCPUs. That's not going to change. Your apps are getting smarter, better, more secure. And we'll get in the details of how this is actually working. So the first kind of accelerator is called an application accelerator. So when it comes to application, there are so many wide range of application, especially when it comes to AI. The accelerator what we have on the CPU is called an AMX accelerator. What it does is, when you do inferencing on CPU, AMX accelerates inferencing such that you will notice significant performance improvement without adding any GPU, without any external card, right on every vCPU you add. Inferencing is not just about inferencing itself. Let's take an example. Let's say most of us are familiar with ChatGPT. When we interact with ChatGPT, you see a nice web browser. On the web browser, you type in the query, then you get a response. There are so many things that goes underneath. The basic thing is that there is a website, there is HTTP, there is API, there is security. Now, when it comes to security, it's over HTTP plus TLS. So that's how encryption happens. Now, many people know that it's computationally intensive. Encryption does not add any business value. You need it because of regulatory reasons or offering privacy and security. The challenge is every CPU cycle that's spent to encrypt every HTTP connection is the CPU cycle that's missed for your application. So if there is a way to remove that encryption away from the CPU and run it on a specialized device, then you have a lot more CPU for your application. That's exactly what our next accelerator is doing. It's called Q80. It's called QAssist technology. What it does is it offloads the encryption from your CPU to a specific region in CPU so that there'll be more cycles for your business applications. It can scale, it can run, just that encryption is offloaded to a particular portion in the in the CPU. It's not just encryption. If you are geeky, if you know how to configure a web server in detail, you can actually enable compression on your web server. It's called gzip, or there are different ways. So basically, your web page will become smaller. There is no difference. All major browsers support this. This can also be offloaded to Q80. So by doing all these computationally intensive tasks onto Q80, you're basically freeing your CPU cycles for your application. Now, I think it's not complete when you just talk about acceleration performance. There is also security that's very key. We talked about security. Typically, there are two types of encryption that we use in a cloud environment. You have encryption in transit. Like we discussed, HTTPS is one way. You have encrypted communication between your client and server. It's completely encrypted. There is encryption at rest. If you do disk encryption, if you use public cloud or if you use disk encryption on your disk, it's also encrypted. So whatever data you write on the disk is completely encrypted. However, when you execute your application, whether it's using HTTPS or anything else, it gets loaded onto the memory. That's plain text. Anyone who have access to the underlying OS, not the guest OS that you run inside the VM, but the host OS, could be a hypervisor, the hypervisor OS or the hypervisor itself. They can actually get the master keys. The master keys is the one that protects whether it's at rest or in transit encryption. So once the master key is compromised, it breaks the entire chain. There is no encryption at all because the key is compromised. That's where we introduced further protection, advanced protection on our Intel Xeon CPUs. There are two levels of protection. This goes hand in hand. The first one is called Intel TDX. So what TDX does is it basically creates an enclave around your VM. So you create your VM, you start your VM. There is no change in the way you're starting or creating the VM. It's mostly a check mark. You need this feature on or off. When you say you need it, Intel and VMware components would ensure that the memory inside the VM is encrypted. You can run your application as it is, no changes at all. You can SSH, you can do whatever you do to a traditional VM. Just that the memory contents are encrypted. Even if someone who has access to the hypervisor, they do a memory dump, they don't see anything at all. They just see encrypted content. Now, you might think that this is how hackers think. You need to be a hacker to do all these things. The reality is that you don't have to be an expert hacker. You don't have to do any hacking techniques at all. It's just a single Linux command or command that you run against a process ID. It dumps the memory. And also, it's not just administrators who are doing this. If there is an application crash and application developers need configuration, they need to know what happened to the application. So it's typically when an application crashes, it also dumps the memory. I mean, there are so many news articles about one of the hyperscalers, how they got compromised. And if you read the article, you can find that the hacker they got access to the private key from one of these application crashes. So all these application crashes, when it dumps memory, anyone who has access to the hypervisor, they can see the key. Now, TDX protects your VM so that even if something of that sort happens, it'll ensure that the content is encrypted. However, for some of the customers, that's not enough. If you see the trust boundary, TDX, the trust boundary is big. There is VM administrator who installs OS, patches it, logs in, checks things, application administrator, guest OS, and then the confidential data. So you still have to trust a lot more than usual. So that's where SGX comes in on the left-hand side. What SGX does is, it has a very narrow trust boundary. It works right next to the data. So you have your data. So as you can see, rest of the things are outside the trust boundary. Not even the root admin can do a memory dump on the content. It works in that layer. So it's typically used in a Kubernetes environment if you want to protect your pod containers to run inside an SGX. It's all fully automated. You just tell Kubernetes that you want your pod to run inside an enclave. Your memory will be running inside an enclave. Your application will run inside an enclave. Some people they like to go further into the details. They don't want the entire container to run inside an SGX. Sometimes what they do is they move only the confidential part of your core to an SGX. The rest of the container would run as it is. Now, this isn't very. You might think that you need to be an expert in using Intel technologies or VMware to use it. But the reality is that it's all pre-integrated into VMware. If you get latest Xeon processor and the latest VMware software, you don't have to do any heavy lifting. It's pre-integrated, and you just have to do a check mark to ensure that it works. You can still use the same CI/CD pipeline. You can still use the same monitoring tool. Everything is the same that you use. Only thing that it's getting better. You're benefiting from the accelerator, and also with better security. Now, here's an example that I've borrowed from VMware's one of the blog posts. So when you're on Kubernetes, and if you have an HTTPS endpoint, you would likely be using a load balancer. You use load balance to bring traffic to your cluster. Otherwise, port-to-port communication, you don't need a load balancer. But if it's any external traffic that's coming, it could also be anything outside your Kubernetes cluster, which would likely be the case. So you use a load balancer. In case of VMware, it's called AVI load balancer. So this is an example where AVI load balancer is getting 3x the performance by offloading HTTPS onto a QAT device. It's the same CPU, it's just that the CPU has QAT accelerator. So AVI is experiencing improved performance just by using QAT. So they have done all the heavy lifting. They have integrated QAT onto the software so that when you use it, you experience this improved performance. The other improvements are mostly software enhancements that has nothing to do with Intel. Now, I hear this question a lot. Do you always need a GPU? Or is GPU, when you think of AI, is GPU the only way? Now, there are many LLM models. Let's say if you're talking about LLMs, so, we have many open source and closed source. If your use case is for a private use case, let's say if you're an enterprise, and let's say if you want to know the data center that you have in Scotland, what's the firmware that's running, what's the Xeon version it's installed, what's the Ethernet version, what's the firmware version of the Ethernet, what OS they're running. This is something specific to you. ChatGPT might not know. I hope they would not know. So for those use cases, you need a small model. You only need a small model that works perfectly fine on a CPU. However, if you also like to know that why do you have a pain on your left shoulder, or why you are tired, then probably that's not the best use case for private AI running on Xeon CPUs. That's when you need a larger model, probably 400 billion parameters or hundreds of billion parameters. That's when you think of a GPU. But if your model in general is smaller, with 20 billion or smaller, you can definitely run it on Xeon, because we have an accelerator called AMX that accelerates inference for you. Now, speaking of accelerators and GPUs, Intel also has a hybrid version where it's kind of a marriage between Ethernet and a GPU. So typically, when you build a GPU cluster, you have GPUs, you have Ethernet, you have to scale it separately. Now, with Intel Gaudi accelerator, which works on VMware VCF5, what it does is it can work on the investment you have already made on your networking. It does not need any special networking. It can work on the Ciscos, the Junipers, or whatever networking that's already there that uses Ethernet. So you connect the Gaudi devices on your VMware cluster, and it doesn't have any vendor lock-in, does not use any proprietary switches, or for example, InfiniBand needs its own dedicated switches. It doesn't work on Ethernet switches. So it can make use of that. It has better TCO when compared to others in the market, and it benefits from the Ethernet technology that you already use. Now, here is an example of how the industry is using different accelerators. I hope the industry you're coming from is covered in this. So QAT is the prominent one that's used widely across industry, whether it's networking or high-performance computing. Because whenever there is encryption, storage, compression, QAT is the go-to accelerator for many of the workloads. And for security, SGX, TDX are the choice if you're dealing with encryption keys or any other confidential information, then SGX and TDX are the go-to confidential computing technology. Now, basically, if you have got latest version of Xeon CPUs, then the only thing that's stopping you from getting the latest and greatest features that we have on the CPU is the version of the software that you use. So by making sure that you use the right VCF software, you can get all the benefits that I've discussed so far, the acceleration that you get out of the box. You don't have to do anything. It's just that VMware will ensure that these functions. I think for many, it's a concern that, OK, we have all these great features. How does it improve the TCO? How does it improve the TCO? Yeah, that's where I think you can walk them through.
All right, any questions so far? All good? Yeah, Ananth did a great job. All right, let's talk about TCO and how we are working with VMware Broadcom on that. So I'd like to start showing this slide here. This is a slide built by VMware. And as you can see, we are comparing three scenarios. One, you have, let me see if I can, I don't have a pointer, but I can show you. So the first graphic is showing second gen, Xeon second gen. So in environment with Xeon second, most of the deployments, VMware deployments today, they are in Xeon second gen. So you can check if you are in that case. You can see how much you can improve that scenario going to 5th gen. We are already in Xeon 6, so it's one generation newer than this one. But again, this is the data that was available. And the last graphic on the right for you guys, right? It is comparing the public sector, right? So you can see how much it costs for, to maintain a VMware environment, depending the scenarios. So I'd like to, get your attention is for the software costs here. It is this blue in the middle, right? So if, no, not that blue, actually it's this one. I'm sorry, no, this one. Yeah, the colors are not helping a lot, like 3 blues I'm trying, but the software is this one, yeah. So if you see the first blue, right, you can see the software is actually increasing the cost. So I don't know if you guys already got in that situation. I love VMware, right? This is my account, but I know they are doing some changes and impacting you guys on the cost. So the cost is increasing. So the point I'm getting here, you pay more in the software, so you have to, modernize your hardware. If you don't do that, like your costs will go, up, and of course you have a lot of issues. I don't think the IT team is getting more budget every year. Usually they are always cutting, right? So this is the scenario I like to show you. And if we go to the public cloud, it's even more expensive. So this is what we are seeing today. And when you refresh your hardware environment, you can see you're saving in other parts as well. So hardware is the second blue, right? I think we should use different colors, right? It would be easier for me to present. So the second blue here, you can see we are saving in hardware, and then you also save in facility, right? And people managing that environment. So you're saving in other things as well. Of course, the software is helping with that as well. That's why we say you need to upgrade both hardware and software. But this is the reality today, right? Broadcom is moving to subscription model. You need to refresh your hardware. Again, this is Xeon 5th gen. I would recommend using Xeon 6, which is the latest version we have available today. And you can see the savings around 40 to 70% comparing with public cloud. Okay. Any questions in this slide? No? All right, so I was talking about, modernizing both hardware and software, right? So you can go and modernize just the software, right? So you have some benefits for sure. Or you can go and modernize just your hardware, and it is the other arrow here. you have some benefits as well. But if you want to maximize your benefits, you need, oh, okay, thank you, man. He was showing like 5 minutes, but actually I still have 10. So if you modernize both, right, you have the best scenarios. So you have all the accelerators that Ananth was presenting, right? So you can start, consuming less of your CPUs for those, workloads like AI, like encryption, storage, right? And then you have, other benefits like the TCO that I just presented, performance, you have better performance, AI accelerators, and then I also presented that, and all the, the tools that VMware has to help you manage that environment. All right? No questions? Okay, when we talk about performance, right? And here is a slide just showing our 5th gen now comparing to our Xeon 6. So one generation older with our latest Xeon version today available. So you can see we have significant performance, gen over gen. Being very honest with you guys, I don't believe a lot of customers would migrate from, one generation old to what we have today. I don't think it makes sense. Most of the customers will refresh in a cycle with 5, 6 years, right? So this is not really reality, but it's just to show you how we are improving our performance gen over gen, okay? Do you know like which environment you guys are using today? If it is Xeon 1st gen, 2nd gen, who's in 2nd gen, for example? Anyone? You are? Okay. So with 2nd gen, like the benefits of migrating to Xeon 6 or even 5th gen are huge. So I really recommend that. Now I wanna get your attention to this tool. So this is a tool we have available, and it is available to everyone. You can go and check the QR code you have on the top. And if you read that QR code, it will take you to a page. You need to create a login. In this tool we call Xeon Processor Advisor. So there are a lot of tools inside, or a lot of elements of this tool inside this website, but one of those is specifically for VMware. So what this tool will do, you put your information there. So let's take, you said you have 2nd gen, right? This is exactly what we are showing here. So you put, okay, I'm using Xeon 2nd generation, and the tool will give you some options. Hey, based on the server you have, the number of servers you have in your environment, you can pick some options. And let's say we pick this one, a Xeon 6 with 36 cores, and then I can see all the numbers that I get when I do a refresh on my hardware. So what is the TCO, right? What is the server consolidation? So if I have 100 servers, what is the minimum number of servers that I could have with the refresh? The performance gains, the break even, how long it would take me to get a return from the investment. And we are comparing that also with the VMware software. So you can choose, am I using VCF? Am I using, VVF, VMware vSphere Foundation? And then you can compare, the benefits on those things. Power, CO2, so all those things in that tool. So it's a great tool. I really recommend you folks to check that out. Any questions? Ananth, we're doing a great job, man. No questions. Okay, I bring Ananth back to the stage to wrap up. So Ananth, with you.
Thank you, Igor. Yeah, this is our last slide. Right. So this is a summary of what we have discussed so far. You have a great software to make it even greater. You need Intel Xeon. With all the built-in accelerators, you can benefit from whatever we have discussed, whatever the performance improvement, and also to reduce your carbon footprint. By accelerating your workload to specialized devices, you don't need all these CPUs to work, all these energy to be used. And yeah, we are here. Feel free to reach out. We are here at the booth. If you like to book a demo on how these things work, feel free to scan the QR code, and we are here. Thank you so much for paying attention.